Hi, I'm Miss Hearn. Welcome to my channel. Remember to like and subscribe. This video is about using polar coordinates, which is a way of naming any point in the plane using an ordered pair r, theta. What is r? Each one of these points, P, lies on some circle, and the radius of that circle is the distance from the center, the pole, to the point. So that's why we call it r. It's a radius. Now, what is theta? Well, theta is always measured from the positive side of the x-axis to the terminal side of that ray that goes through the point P, just like normal. So it's measured from the polar axis to the ray that goes through P. It can be measured in degrees or it can be measured in radians. It doesn't matter. So in this example, we're just going to plot the point 315 degrees. 3 is our radius r, and 315 is our theta. In which quadrant does the terminal side of 315 degrees lie? It lies in the fourth quadrant. That's right. How far into the fourth quadrant? Well, 315 degrees is 45 degrees less than 360, right? So it's going to be right in the middle of the fourth quadrant. Now, R tells you the distance that your point is from the center. So if we count the rings, we're going out to the third one. So this would be the point 315 degrees. Now let's see what the heck it means when you have a negative radius. So if you have a negative radius, you're still going to start the same way we did a minute ago. We're going to focus on theta, and we're going to go to the angle pi, which is on the left side of the x-axis. What the radius represents when it's negative is still a distance. The distance from the pole is the absolute value of -2, so 2. What the negative represents is a direction. That is the opposite of the angle pi. If pi is headed directly to the left, then we're actually going to look directly to the right. This would be the opposite direction, but still a distance of 2 from the pole. So our point is going to lie here. We're going out to the second circle, and this is the point -2, pi. Now, how could I name that same point, but with a positive radius? 2, what angle is it lying in the same direction as? 2 pi would work. Did anyone else think of another angle? 0, that's right. 2, 0 would work also. There's actually an infinite number of ways to name any one of these points when you're using r theta, because you can give it either a positive or negative r value, plus you can go around the circle as many times as you like. And you can use negative angles as well. So this could also be 2, -2 pi or something like that. -2, what would also be the same point? Negative pi, yep, negative pi would work. Negative pi, we could do -2, 3 pi. Anything that has the same terminal side as pi, we can put right here and match it up with -2 as the radius, and it'll give us that same point. And an infinite number of ways that you can name one point. All right, go ahead and plot the point -1 pi/2 on your paper and see if you get it right. Does everybody have something plotted? All right, so is this where you plotted your point? How did I get that? I had to go to -pi/2. -pi/2 is down here. So why is my point up there? Because the radius is negative. So if the angle goes directly down, then with a negative radius, you have to go the opposite direction, which is going straight up. Okay, good. Now, in general, if you want to find different representations of a particular point r theta, you can basically take the point r theta and just add any multiple of 2 pi to theta. And of course, that's going to have the same be on the same terminal side and the same distance from the pole. On the other hand, if you want to find points that have the opposite r value, you can do pretty much the same thing. It's just that you have to go halfway around the circle. So add pi to theta, and then add any multiple of 2 pi to that, and you can keep generating new points. So you will see questions like this. You will be given a point and asked to find versions of that same point with certain characteristics. So in part A, we're looking for a new name for the point 5 comma pi over 4, where r is positive, theta is between 2 pi and 4 pi. Okay, so where r is positive is going to be the same sign as the original because it was already positive. So what that means is we're going to use the rule r theta equals r comma theta plus 2n pi, the formula on the left. What multiple of 2 pi do we want to add to pi over 4 so that we will end up somewhere between 2 pi and 4 pi? Do you want to let n be 0, 1, 2, -1, -2, -3? What do you want to do? So that it'll end up between 2 pi and 4 pi. 1, right? Isn't it true that if we start at pi over 4 and go one time around, we're going to be just past 2 pi. R is going to be 5. And then we're going to have pi over 4 plus 2 pi. 9 pi over 4. Yeah, good. So we're going to have the point labeled 5, 9 pi over 4. If you had trouble following that explanation, it might be helpful to draw a picture of it to help you follow along. So I'm going to go ahead and plot 5 pi over 4 would be here. So if we want to keep r the same and be on the same terminal side, but have an angle between 2 pi and 4 pi, isn't it true that we just need to go around one more time? And we will pass 2 pi. So you can think of n as the number of times we go around the circle. We're going to go around one more time. And you could always just experiment with different n values until you get one that fits, or you can try to visualize what's happening. All right, what if we wanted r to be negative and theta to be between 0 and 2 pi? Okay, so if r is negative, then we want the opposite sign of what we started with. So we're going to use the other rule. R theta is equal to the opposite of r, and then theta plus pi plus 2n pi. So that's going to be -5, and then we just have to figure out the appropriate n. I have to figure out how many times we want to go around. So the pi is going to put us on the opposite side, and then we're going to go around how many times more if we want to have an angle between 0 and 2 pi. I would say no times more, right? 0 times more. Isn't it true that this terminal side is already between 0 and 2 pi? So what that means is that just doing theta plus pi and n equals 0 will work. What is pi over 4 plus pi? 5 pi over 4, right? So this is saying if we go from 0 to 5 pi over 4, and then go backwards 5 units from the pole, then we'll end up in the same place. So this is -5, 5 pi over 4. Now let's do one more. They want r to be positive, and they want an angle between -2 pi and 0. Which formula are we going to use? The first one, right? Because it's the same sign that we started with. So we're going to use r theta. R is going to stay the same, and then we're going to add multiples of 2 pi. But what n would work so that we would get an angle that's between -2 pi and 0? Would n be a positive number or a negative number? Negative. Would it be enough to go around just one time? And would using -1 work? Let's check it out. So if we use -1, we would get 5, and then we'd have theta, which is pi over 4, and we would be subtracting 2 pi if we use n equals -1, right? So we would be going 2 pi in the negative direction to get back around to here. So what angle would that be? That would be the angle that terminates here, starting at 0. 5, -7 pi over 4. So that would fit the characteristic of being between 0 and -2 pi. We only had to go backwards one circle, not even one whole circle. I hope you found this video helpful. If you did, please give it a thumbs up. That will help other students to find the video. You can also subscribe to my channel, Miss Earn Mathematics, for more math videos.